Okay, great. Let's give it another minute or two, and then we can start. Great. So it's 12:30. I think let's get started. Thank you everyone for joining us today. We've got a very special guest, Ivan Lin. So Ivan, where are you? Are you in Joburg today?
Yeah. Been here for those 5 months.
And we've got Wessel, one of the architects from Gas Architecture Studio, and Wessel will just introduce Ivan.
Hi everybody, my name is Wessel van Dijk. Yeah, I've been working with Ivan for a couple of years now on various other projects, and really when it comes to acoustics and sound, I had the privilege of seeing his own, almost like a movie theatre at home, and I call it a movie theatre, with all sorts of fancy stuff. So yeah, it's really nice to have Ivan here. He actually refers to himself as a space enabler, not an acoustic engineer. I think that's quite a nice word or a term for what he's doing. Yeah, Ivan, thank you very much. Over to you.
Okay, I think I'm just going to launch into the talk. I think if that's okay, I'm going to start with talking about the few topics we're going to cover. We're going to talk about what is acoustic and psychoacoustics, and then we're going to talk about hearing and listening, and the acoustic in education environment, and how we apply this in the design of the Green School, and what we did on this project. Okay, I'm going to start with a question many have contemplated before. If a tree falls in a forest and no one's around to hear it, does it make sound? This is an age-old philosophical argument regarding the possibility of perceived existence. Luckily for this talk, we can take this approach since the word acoustic comes from the Greek word acoustikos, probably sounds like Greek to you, and it means hear. Again, we actually don't know if the tree made a sound, because if we don't hear it, was it there at all? We'll come back to that later. Acoustics about the science of sound. However, for me, I'm more interested in how humans perceive sound and therefore the psychological response to sound. I prefer to call it psychoacoustics. So it's really about how we react to sound that's more important rather than the science of sound itself. And in many ways, acoustic to me is a living science. It's not pure engineering, pure science. We just actually make it into numbers and quite meaningless. So that's what I would like to call psychoacoustics rather. Human sensory systems to the outside world are basically based on a few fundamental mechanisms. In other words, perception of vibration, be seeing light wave vibrations, hearing through airborne vibrations, touching through tactile vibrations, tasting through chemical reaction, and then translate to electrical signal to be perceived by brain. It's all based on vibration. And it's just different form, different frequency range. However, humans live in a very narrow band of perceived existence. We can only see a limited light spectrum, hear a limited frequency range. Dogs and bats can hear far higher frequencies, so their idea of the world and existence is actually wider than ours. Okay, that's an entirely different talk altogether. That's actually very interesting. We actually live in a very, very small slice of the universe that we know. There's so much out there in the low frequency range, high frequency range that we don't know, and therefore it's not there for us, and we don't actually believe it's there. So, Alva, you're welcome to chip in if you like. Yeah.
Thanks, Ivan. I was just thinking that within the range of sound that we can hear, how does it vary from one human to another? You know, if you're thinking about the sense of smell, there are some people with a very acute sense of smell, and then some people that hardly smell anything. Is it similar to hearing? I've never thought of, you know, the sharpness of sound or whether it's different.
It is. Actually, that's a very, very interesting, important question. Scientists tell us that we hear, well, as human beings, we hear between 20 hertz to 20 kilohertz. And however, in reality, most of us, we probably hear between about 80 hertz to about 15 kilohertz. And mainly because below about 100, below about 100 hertz, we start to feel rather than hear. Below 80 hertz is more vibration. We feel the vibration of the pressure on our body rather than actually physical hearing low frequencies. And by the time we get a bit older, when we go beyond about 50, most of us actually lose hearing, high frequency hearing range quite rapidly, about 15 kilohertz. So the frequency range we hear is common, but become nearer and nearer. And at the same time, we know that we see color differently, and we do hear sound differently. And also that because how we hear sound, or how we understand sound, is very much based on the cultural background, language you're speaking, and then the environment you grow up with. Our association with it can be quite different. But with same as color, we all agree on same colors: brown, green, yellow. We might see differently, but we agree to be the same color because of common language, rather than how we actually see it the same way.
Wow. So if that idea that sometimes if someone speaks to you in a certain pitch, that you really don't hear it, it is possible.
Well, within the common human speech frequency range is quite narrow. Typically, it's about 200 hertz to about 8 kilohertz. So it's still quite within the range we can perceive. So it's quite easy to understand here human speech. It's not really, unless that one chooses not to understand, which happens quite often between people. And some people do find a certain people's voice and the frequency range quite irritating. And sure, we do all have come across people like that. So yeah, and I don't think it's the mechanism. It's more about how our psychoacoustic response to it.
You know what you're saying, with some people's the tone of voice is quite irritating. I've never thought about sound that way, but it is so that some people's voices are so beautiful to listen to, and some people just really not. And I also wonder, is that different from one person to another person, or do we generally find the same people's kind of voices irritating or just really beautiful?
Gosh, I think if I cannot want to generalize, yes, probably, but I don't think I should generalize that because we're also different. And but yes, you will find a group of people that recognize one of their friends quite irritating how they speak. So yeah. Not from a scientific perspective. I shouldn't have made it kind of comment scientifically. Yeah.
Great, thank you, Ivan.
Okay.
Ivan, from a teaching point of view, it's not so often volume as just all the other noise that's going on in the classroom. And you know how absorbent the surfaces are and how reflective they are. And auditory discrimination. So as a child, can you hear the teacher's voice and all the other noise that the other children are making, and being able to separate those sounds?
Yeah, actually, you know what I'm going to do? I'm going to come back to you. I'm going to answer your question, but later, because part of the what I'm going to talk about is actually we need to talk about some fundamentals about how we perceive sound. Then I can answer your question more adequately. Shall I carry on? Okay. So we're going to quickly talk about hearing and listening. And I think once we get that difference, we will understand better. Hearing is the first sensory awareness we acquire as a human being during the fetal stage. Typically, the ability to hear sound is already developed between 16 to 18 weeks during the fetal stage. During this stage, one of the most prominent sounds we perceive is our mother's heartbeat, roughly at 72 beats per minute. When mom gets excited, it beats faster. When mom calms down, slower. This is quite profound. Think about the implication to human civilization. After we were born, we continue to create beats and rhythm to make us feel excited or calmer in the form of drum beats and music. Can we imagine that a world without music, or can we imagine a world without rhythm and beats? It's so intrinsically embedded in our daily lives and what we are and who we are. And we hear 24/7, even when we sleep. Hearing is a primal survival skill. We need to hear danger even when we are not consciously of our hearing. But it is important to differentiate hearing and listening. Many parents say their kids don't listen. Actually, they do hear, but whether they provide an agreeable response is another matter. Hearing is a neuromechanical process, but listening is an intellectual one. It is important to know that we hear with our ears, but we listen with our brain. That's a very important understanding. Okay, ears pick up audio signals, but our brain interprets the signals and makes sense of it. The important word here is interpret, because when we interpret, it is not guaranteed that perceived information is indeed the correct information. So this is building up to answering your question, Andy. Similar to our ability to read and comprehend misspelled words in a sentence, in a phenomenon that has been dubbed typoglycemia. Even without realizing the words have been misspelled, we can comprehend spoken words heard in a non-ideal environment. For example, noisy or reverberant environment. Interestingly, this phenomenon is only documented academically in 2017 by scientists in the University of California, San Francisco. So it's a very, very recent scientific study. So I'm sure we all have experience in trying to have a conversation in a highly reverberant or noisy environment. For example, noisy restaurants or traditional school halls. Even though our brain can guess and probably comprehend most of the words, it can be very tiring. It can really be exhausting eating in a noisy restaurant. Why? Because we use subconscious brain processing energy, which is typically between 20 to 25% of our total body energy consumption. It's actually amazing that how much our brain consumes energy compared to the rest of our body function. So now, apparently, one cannot think harder to lose weight, but we use a lot of energy by thinking. So this is really to actually illustrate that we hear with our brain, and the brain does all the work in trying to understand rather than just through passive hearing. And so next we're going to maybe touch on acoustic in the education environment. What is the purpose of the school? I believe it's a place where we do knowledge transfer, in other words, teaching, learning, and exchange of ideas. One of the most important functions in a school, if not the most important function, is communication. Audio communication is by far the most important communication mechanism. In this COVID-19 era, we can happily use Zoom, Team Hangout meetings in audio only without seeing each other face to face. But without sound, it is almost impossible to communicate effectively. So audio is the primary knowledge transfer medium. From my perspective, a school is a place to hear and to be heard. We can have brilliant teachers and beautiful classrooms, but if we cannot hear or to be heard effectively in a classroom, we have a fundamental barrier in how successful a teaching space can be. Many of us have grown up in a classroom that consists of hard sound, reflective seating, and walls that are actually quite reverberant. In addition, windows could be open so we can hear sports activities or even traffic noise outside the classrooms. The two fundamental limiting factors that prevent speech transmission is excessive reverberation and high ambient noise level. These are the two keys challenging preventing us achieving speech quality transmission in a typical classroom. And now the measure used to measure quality of speech transmission, one of the common descriptor we use is sound transmission index, STI. It's a common use to describe the quality of speech transmission in a given space. In our case, we typically measure from the front of the classroom to the back. We have learned from past measurements in a typical classroom, STI can measure poorly up between 0.3 to 0.4. This roughly translates to an understanding about 30 to 40% of what a teacher says when a young child is sitting in the back of the classroom. It's quite frightening when we actually realize it's that little. And so we have spoken about we listen with our brain. The ability to fill in missing words might be easier for older children and adults, as life experiences help to supplement the ability to fill in missing or incorrectly heard words. Unfortunately, it is more challenging for young children to comprehend the knowledge transfer that should be taking place effectively in a classroom. And they cannot make up the missing information from their own knowledge base as they are still trying to build one. Their minds wander off. Something else could be more interesting. Could this be the reason why kids sitting in the back seem to be more naughty and distracted? For them, the tree did not fall, or maybe they didn't even exist. So it's actually quite interesting that we often say, no, the kids are sitting in the back. But in reality, they actually don't get what the teacher is saying. And there's one of the primary factor, they're being distracted. So, so indeed, I don't know, I could partially answer your question up to this point.
Yeah, it's ensuring that, as you say, there's an optimal learning environment where everybody can hear. There's a lot of research to show that in the average classroom, most of the children at the back cannot hear well enough to really follow the lesson. And I know that you put a lot of work into ensuring that the sound distribution around all of our classrooms at Green School will be equal, so that every child will be able to follow the progress of the lesson.
Yeah,
and that's going to make the learning experience of students at Green School quite fantastic.
Yeah. Well, interesting thing is that, we actually been doing work with the research department in Wits in Laos here, and what very interesting outcome was that beta acoustic and beta quality speech transmission in the classroom is actually not difficult to achieve. We have found a typical cost of providing adequate acoustic in a classroom is typically equate to a cost of a laptop computer. And this is actually surprisingly low compared to the benefit that can be achieved. And thinking about majority of the government classrooms out there, just really a bunker. Well, they're lucky to have a roof over their classrooms. But when they do have a roof over the classroom, it's a concrete slab or a hard gypsum board. And it's so reverberant, it's difficult to have a conversation. And no wonder, apart from the poor facility, it's actually challenging to teach and learn in this kind of space. So let's carry on to what have we assisted with Green School on this project. I must say this is actually really exciting that how we approach this project is so different, mainly because we're not using conventional material, and we're not thinking in a conventional way, using standard off-the-shelf material. And so it challenged our thinking, but which is fantastic. So the two main things we're dealing with, again, is trying to control reverberation, and number two is ambient noise level. So to control excessive reverberation, one of the easiest things to get right in the classroom is to ensure we have a sufficient area with appropriate surfaces to control excessive reverberation. So in our case, it's actually the easiest place to do is actually the seating area. We're trying to choose surfaces that people don't get to touch, and we don't need to finish it and cover it. So seating is always the cheapest and most effective way of doing it. And in our classroom here, we have managed to combine thermal and acoustic in the composite layer. So acoustic material typically is actually quite economical. It's actually how we're trying to finish it to become more expensive. In our case, acoustic material is actually work in a sandwich with the thermal material. Maybe I should actually share screen here.
Right, let me quickly give you access. Should work, Ivan.
Yep, got that. Can everybody see?
Yes.
Okay, so this is our roof here. We have a sheeting roof. Under that, the two main components here is an iso board for thermal insulation, but below that there is a layer called polyester fiber. Here it's called thermal insulation, polyester iso board. But in any case, so the polyester fiber used here is actually made from recycled polyester PE bottle, cold drink bottle. So it's actually a very good recycled material. And underneath here, we've got a resealing. And in a typical commercial environment, we're always trying hard to hide acoustic material by fancy finishes, perforated metal sealing paints, sometimes stretch fabrics. But in our case here, because we have a resealing and between there is a lot of air gap. So it's actually quite a good surface covering material. What's important is we need to allow some energy to go through the reed area to be absorbed by the sealing layer. Okay, and we have calculated that if we cover most of the sealing area, we actually can achieve quite a reasonable reverberation time for our requirement here. And treating sealing is just one of the mechanism, but it's very much related to the size of the space. For larger spaces, it's more difficult to just treat a sealing, which might need to provide certain kind of sound reflective sealing material through the direct speech from one side to another. Can you still see the screen? Okay, so this is a cross section of Sandcap auditorium, where there is a stage area and there is a performance area. Sometimes it can be vice versa, stage area and sitting. So we have designed, it's a bit difficult to see if the interior designer has proposed very nice cloud-like ceiling panels free hanging from the roof, but we try to model the geometry and angles of these panels. You can see these blue lines are designed to provide sound transmission from this dimension, or from this angle to this for people standing here, as well as if you are standing in front here, when you speak, can be transmitted to the back on top of the stairs. So these panels are designed to be bidirectional, to assist bidirectional communication. And so, yeah, so this is really the two main criteria we designed, and I'm sure there are a lot of details to be developed by the interior designer. Unfortunately, we can't show it now. So I think, I see we only have a few minutes left, but I think one important point I'd like to make is that a functional space is a green space, but many green spaces are energy centric. And most of the green building have been involved with in the past spend so much energy, concentrate so much time and energy trying to save water, save electricity, but they're not necessarily functional. I believe the minimum qualifying criteria for a green building is that the space must serve the intended purposes and it must serve them well. Otherwise, how green can it be if we spend all the energy and resources building a green building, but the space is dysfunctional? And that's where the human interface and acoustic come in to make it work.
Now, Ivan, I've never before considered that the acoustics and how well you can hear and listen in a space, you know, would be a measure of how well it's been built. But after listening to you and previously engaging with you, it's just such an obvious thing to do in all spaces where you communicate.
Yeah.
You know, whether it's a school, whether it's your workplace, actually whether it's your house, you want to hear and to be heard in all those spaces. And if the sound is annoying and doesn't work well, then the space doesn't work well. Yeah, so we've got a question from one of our participants. Jamie asks, In an open classroom concept where you have no walls for sound to bounce from, what are some strategies that we can employ to ensure a balanced sound distribution so that all students can hear effectively?
I lost you for a little bit. It's okay. The open, if I understand it correctly, the open classroom philosophy is something that, interestingly, there have been quite a few examples done in Sweden and the UK in the last 10 years, and it's been extremely challenging because it's a model on the philosophy that we must have an open flow of learning and interaction and all that, but the noise factor has become a very limiting issue with teaching because the kids get distracted so easily by other activities around them. So it's not easy answer to I do know that one or two of the open schools in Sweden, which are one of the pioneers in open schooling concept, they should force to provide partial enclosures and need to provide a lot of sound absorption in the open plan classrooms. Because it's in a human factor, end of the day, it's what determines how we interact. And if we just think about how we interact without thinking how we hear, our interaction is severely limited. I don't think I'm answering this question entirely, but yeah, just giving you the background on that.
Thank you. Then Michael is asking, in a project-based or collaborative philosophy in education, you have a classroom that can be quite noisy while teams of students work together. Has there been any thought about how to limit some of that noise, or it can be hard to concentrate at the group level?
Okay, well, that is a challenging one. Sound is carried by air. If air can flow, sound will flow. It's really as simple as that. So only way to stop noise from one space to another is through physical barrier. And this quite often in the design world, people are confused between putting things on the wall to absorb sound, then providing barrier to isolate sound. So in terms of the interactive environment like this, to reduce noise without a physical barrier is almost impossible. I wish I can win a Nobel Prize by inventing something, but having to find a way to do that. So yeah, it's difficult. Yeah.
So something, and adding something like plants, pot plants in a room and screen. So that would lead through air, so it will lead through noise.
Yeah.
And glass barriers.
Sorry.
What happens if you add a glass barrier?
That's a very good question, suggestion. Just a different example. In call center environment, sometimes, or in the open plan office environment, the typical screen height is about 1.2 meter, which is actually utterly useless because we can see each other across the desk, and sound will still go through the barrier anyway. So one key property in the open plan is transparency and visual openness. So yes, we do encourage putting glass screen on top of the existing screen. And some in some of the building we've been involved, we actually add the glass screen to about 1.5 meter high. And interestingly, I was actually discussing with one of the stock exchange company in New York, and they actually managed to enclose all their stock traders to 1.8 meter high enclosure, because even 1.5 meter doesn't work for them. Yeah, but on the back of that, it's very important to be transparent because some other company put people in a 1.8 meter enclosure. They got worse because when you're in the enclosed environment, you get a false sense of privacy. Then you talk louder on the phone. You don't actually think about people around you can hear you, even though you can't see them and they can't see you.
Perhaps if I could add in there, a major part of that question is to do with managing the class and ensuring that you haven't just got a very loud, noisy environment. I spend a lot of my time in classrooms, and when students are in groups and working together, there's quite a purposeful buzz. But when you go down to the lunch hall, the canteen, the dining hall, everybody's shouting at the same time, and the volume level is almost deafening. Interestingly, children love it there. And they thrive in that crazy normal environment. So what we want to ensure is that in the classrooms, there's a purposeful kind of professional academic volume level. In teacher talk, we say, now use your indoor voice. Don't talk with your outside voice inside. But a lot of it is about managing that, and the students are pretty good at managing that. And you will know as a teacher, as a head of school, when you're walking around and you can hear the purposeful buzz of kids working together, and it's a wonderful sound. And then perhaps you walk past the dining hall and it's just noise and craziness, but children love that kind of environment. So it's about managing student behavior and wanting to have places that are buzzy and vibey, but there's still the acoustics where you can work purposefully together.
Yeah, I think Andy brought up a very important factor that we explore a lot of new model of working, either in commercial environment or the education environment. And however, one thing we haven't done enough is actually change behavior change and behavior management. We can't change how we work and how we teach without changing people's behavior. So that's a very important factor. Yeah.
Ivan, thank you so much for joining us. Let me see, there's one more thing in the chat box from Michael. No, I think we've addressed that. So yeah, so thank you very much for joining us. It's been a huge privilege to work with you, and thank you for the contribution to the school and all the different spaces. Thank you everyone else for joining us. We've got a recording of this talk from Ivan, and if anyone is interested in getting it, I'll send out an email, and you've got my contact details too.
Thank you. It's been such a pleasure.
Thank you, and have a good day.
Take care. Cheers. Bye.
Thanks, Ivan.
Cheers.
Thanks very much, Ivan. That was great. Thank you.
Thank you. Okay. Bye.